Yes, I'm back. So you can see I erased some stuff, or maybe you can't. It's two videos, then why bother talking about the other one? Anyway, here we are talking about another energy and momentum connection. Um, in this case, we have a block of mass m that glides, slides down this frictionless incline from a height h, and it's going to whack into this uh, mass we'll call lowercase m, and we're gonna say it's inelastic, and then they're gonna together do this and fall down there, right? They're gonna turn into a horizontally launched projectile, right? So there's really three parts of this, and let's say we want an expression for this that we call delta x. Well, we'll have to say that this um, table has a height delta y. That's something we'll have to throw in there. We'll say that this thing starts at rest. So what I did was I added a slide on the next page for me to have some more room to deal with this. All right. So there's really what I can sort of think of as three things to look at. One, block M slides down that ramp. Well, how do you know if things are momentum or energy? The big deal is if there's one object, it's not an interaction. And momentum things are interactions. So one object, that's a conservation of energy thing. Here's something where we're trading, height here for speed here. Okay, so what I would say is that if this thing's frictionless, ME initial equals ME final, or let's see, GPE initial plus KE initial equals GPE final plus KE final. Well, why don't we, for this part, call this height 0? Okay? Well, that means we can get rid of this and this. And we get M, GH, right? We said this was our height H, equals 1/2 M V final squared. Well, we're used to this. I hope we get rid of these M's. And we say that the block big M at the bottom of that, well, as it slides right here, has a speed 2gh, right? So there's sort of, phenomenon one. Phenomenon two is the collision. All right, so what we say now is that the sum of the initial momenta and the sum of the final momenta are equal. Or M1 V1 initial plus, well, how about this? Instead of ones and stuff, we'll write it as M V initial. Well, a little block, little m here, big M here, little block M isn't moving initially during the interaction, before the interaction. What's up, Ross? Don't mind me, Ross, I'm just talking to the board. And afterwards, the two stick together, M plus M, and they move at some final speed. Now, not the same as this final speed. See you in a few, buddy. Right? This speed here is V, 2gh. What we want to know is, here's what we're calling V final. How fast do the two things go after the collision, just after the collision? Well, that means our expression Vf is m times Vi over m plus m. Now notice, the final velocity for when the block is sliding down the ramp is the initial velocity for the interaction. So we would say that this is, let's see, Vf is m square root of 2gh over m plus m. Okay? That's their speed as they leave the table. And then they leave the table and do this, and again we want this delta x assuming they fall some distance delta y. So we'll call this the projectile part. I have noticed, folks, believe me, I have noticed that our projectile problem-solving skills are weak. Are weak. Okay. So we got to. I don't know. I think it's a good reason to do this problem. All right. We'll always do things like this with a projectile problem. What's up, bud? Yeah, cool. Thank you. Thank you. Fresh out of the dryer. Thanks, buddy. Right, separate things into x directions and y directions. Well, we have our Vx. It's that stuff. Remember, this is a horizontally launched projectile. That's the deal with every horizontally launched projectile. If you don't know what I'm talking about, go back and look. Okay? We also know that A is G. We also know that there's, this delta y. Well, and we want delta x. There's only one equation we ever use in the horizontal direction, and it's delta x is Vx times t. If you don't know why, go back and look. All right, so the question is, well, we know what Vx is, right? It's this thing down here. The question is, how long does this thing spend in the air? Well, if you remember, with these kinds of problems, yeah, we want something on the x side of this table. We're going to have to go over here and find time. And then use that same time back over there. So here's what I would say. I would say that, well, delta y is v naught yt plus 1/2 gt squared. Since v naught y is 0, that goes away. Delta y is 1/2 gt squared. Therefore, t is the square root of 2 delta y over g. All that stuff goes in there. So that means that we can really write an expression for delta x. How far does it go? Well, it goes Vx times t. No, it's not totally out of the realm of possibility that this is a real kind of question. All right? The question would not be, here's the whole situation, write an expression for delta x. The question would certainly, this is absolutely no problem, fair game. All right? I find this, I assume that this is absolutely no problem, fair game. All right? Here's a little bit of an extra stretch, just because it's been a while since you've done projectiles. But as you've seen on tests and quizzes, I will go back in time and assume that you can still do stuff we used to do. All right, I can't have you just, when a unit ends, just say, well, I don't need to know that anymore. You do. Okay? There are other kinds of these problems. There are some on the original momentum and impulse worksheet that I gave you. So we'll get cracking on those on Tuesday. All right? Wednesday we'll start a new unit. The test on all things momentum and all things energy is Friday, as you've seen on the Edline calendar, of course. Okay? Make sure you can do those, if you haven't finished those yet, work through those two-dimensional interaction problems. We can talk about those on Tuesday as needed, if you'd like. I'll also say this, folks, we had a lot of people doing a lot of staying after in the first maybe 4, 5, 6 weeks. Well, really in like the 3rd, 4th, and 5th and 6th weeks, people were doing a lot of staying after. And I think people got pretty comfortable after a while, and no one stayed after in a while, which is okay. If you feel real comfortable about it, then that's fine. But know that that's a real helpful tool, or can be a real helpful tool. And I hope if you need it, you're still feeling like you can stay after. Right? I'm here every day except Fridays, pretty much. Although this is a Friday. I mean, it's 2:52 right now. Here I am making a video. Anyway, have a good weekend, people. Enjoy a good long weekend. And that is it, and that is all. See ya. Oh yeah, and that lab, you're gonna give it to me when? Tuesday or Wednesday? That two-dimensional collision thing that we did with the marbles. Um, well, we can say Wednesday. Just, you're gonna have to do it at some point. Nah, scratch that. Do it for Tuesday. Yeah. Haha. Do it for Tuesday. Right? You get a long weekend. Getting busy. See you, folks.